Hello, welcome to my presentation for ATIA 2021, Context and Effect, Multimodal Switching for Communication and Control. I am James Schorey, Chief Technology Officer for Control Bionics, Incorporated. And as I said, I am with Control Bionics. I am their Chief Technology Officer, and I receive a salary from Control Bionics. I'm here to present on the Context and Effect device that we have, which is a companion product for our NeuroNode. And since there really are no like-kind products available, this presentation will focus exclusively on the Context and Effect. Our learning objectives for this session are three. One is to compare three access methods available for communication and control, discuss how one user interface and multiple access methods can be used for three outcomes: to control toys, robotics, and games. And finally, to demonstrate how thoughtful design can allow a single switch input to control multiple outputs. That is, a single NeuroNode activation. How can you create a one-to-many relationship where that activation can switch out more than one switch and control into an Xbox game, for instance. And of course, feedback is very important, so make note of this slide and pause it as necessary. What is the context and effect? It's really three things. One is it's a device to allow the NeuroNode to control robots and toys and gaming devices. It's an accompanying app that allows us to build a communication and control ecosystem that again allows us to map a single user switch or a few user switches, 1, 2, maybe up to 4, but to map that into many switch outputs. And then finally, it's a system that allows user-activated transitions among access methods. For instance, to control a dining robot where some of the time you need to communicate needs related to dining, and some of that time you actually need to control the robot itself, the dining robot. The major components of our context and effect: one, there is a physical presence, and that is a small box that has 8 switched outputs. Those are the outputs that get connected to an Xbox adaptive controller or toys or a robot of some sort, like the OB dining robot. The application for the C&E itself runs on a Windows computer, connects to our C&E box with a USB cable. And then lastly, there's a RFID reader built into the C&E so that you can change the personality of the machine completely with the swipe of a card. For instance, going from gaming with an Xbox to a toy control or the OB feeding robot. Let's start with the OB dining robot as our first example. And the OB requires 2 switch inputs, so we need to output two switches out of our context and effect box. One key input or one switch input for the OB is to select the food, and that is to move a spoon over the compartment where your food is, the one that you want to select. And then the second switch is to actually scoop the food in that compartment and deliver it. So in our example, we will use a short activation to select the food, to move the spoon. And then we'll use a long press, as it's called, that is a longer activation, to request scooping the food and bringing it to a pre-programmed position. And of course, that would be the diner's mouth. Now, there are other panels in the C&E dining ecosystem, and these panels are really for control and for communication. what you see on this slide is the main menu. So you can go from the top button, and that is controlling the robot, to asking for more, to saying that I'm finished, to going to another panel that has more choices and communication related to getting help with the dining. An important part of the experience is timeouts that you can build into the the context and effect. So for instance, after some amount of time, if you aren't advancing the spoon and you're not delivering the food, then the C&E can make the assumption that you're either done or you need to communicate some other need related to dining. And here's a case where this is some help that you might need apart from the actual dining. And one is, can you wipe my face? Or can you fix my OB, for instance, if the spoon has too much food that's stuck to it? Just many practical matters. One is repositioning. Can you reposition me so that my target position is a little bit better for where the food is delivered? The idea is that uh, with the control of the dining robot and with communication that's wrapped around it, the idea is that uh, the user can dine along with someone without that person being the constant caregiver. The idea is that the person is more company rather than caregiver. We have a demonstration here that this is connected to me with the NeuroNode, but you'll see that um, this is essentially how the C&E works as far as controlling the robot. And the important part here is that you don't have to look at the context and effect app. The prompting and uh, the control that's needed allows you to focus on the task at hand, in this case dining, but it could also be game playing where you're not looking at the C&E application window, you're looking at the Xbox display. So here is that video.
Okay, this is a video of the NeuroNode and a specialized app that I've been calling the NeuroNode Cause and Effect that controls switch outputs, and the OB feeding robot, which is this guy right here with its carousel of treats. This is the specialized application for interfacing to switches, whether those are Xbox or toys, or in this case, a feeding robot. And of course, this is the NeuroNode. And the way that I have this set up is I'm controlling this with a single NeuroNode. I have a short press for select my food, and then the long press is for feed me. So you can see as I go through here, I'm making my selection with each short pulse there. Now, if that's the food that I want, I just make this a long pulse, and he's going to dig into that food, and he's going to deliver it to a pre-programmed place that is right by my mouth. Of course, I'm not sitting here just for the illustration of this. And that's it. That's the NeuroNode with our specialized app for switch control and the OB feeding robot. Thank you.
Our second example is Xbox Power Star Golf. So it's a gaming example on the Xbox, and in order to make this work, we have the Xbox Adaptive Controller. The C&E box is connected to the Xbox Adaptive Controller, and the Xbox Adaptive Controller then acts as a controller for the Xbox. We need, rather than just 2 switch outputs like we did with the OB dining robot, we need 6 outputs. A and B and X and Y buttons, and then left and right from the like the crisscross joystick buttons on the controller. So 6 controls altogether. but we're accessing all of them with a single NeuroNode activation. Most of the game is played just with a swing that's initiated with the A button. Essentially, when you're driving, you're pressing A to start your swing, you're pressing A to set the power, and then you're pressing A to set the accuracy. And those activations are one after another. So it's handy to have the NeuroNode for that because it requires very little activity, virtually imperceptible movement in order to make that activation. And of course, the countdown timer works here too. So if you're not swinging, the C&E understands that you probably need some other function. So it transitions to an intermediate menu to allow you to adjust your putter. And if you need to from there, you can go to the main menu to access all of the controls. And here is that intermediate menu where you can adjust your putt. So the first top buttons, the two top buttons, that's left and right. So you're angling your golfer left or right to account for the slope of the green and for the wind conditions. The third button down is just to go back to your play screen, your panel where you're just activating the A button. And then the bottom button allows you to navigate back to the main menu so that you can access all of the controls for the Xbox. Of course, as was with the dining robot, an important part of the experience here is that you really don't need to look at the C&E window at all. You're wanting, of course, to look at the Xbox display. So by prompting and context, you always know where you are in the C&E ecosystem as it relates to playing the Xbox game. And one of the goals, of course, when you design one of these ecosystems is to make it so the user can play or perform a particular task for long periods of time without any intervention at all. And that translates, of course, to long periods of play equals lots of motor skill practice. So let's see an example video of this is myself using the NeuroNode to play a par 3 hole. Hello. This is a demonstration of the NeuroNode combined with the Context and Effect app and Switchbox to allow us to control an Xbox game, in this case Power Star Golf, through the Xbox Adaptive Controller, which the Context and Effect box is linked to. And the first thing we need, of course, is a switch. And what makes this important is with a single NeuroNode switch, which is what I have on the display here. So let me relax. I'm going to completely switch and control the game with a single activation of the slightest movement of my index finger, as if I'm grasping something in my hand and just looking for finger flexion here. So those will be my switches. And the Xbox ultimately will get these switches, but it goes through the context and effect. And the context and effect will take a look at where we are in the golf game, and it will reroute the switch to the appropriate control. Sometimes we will want to hit the ball. Sometimes we will want to use a cursor to adjust our angle for our putt. And sometimes we'll want to make other menu choices. So the context and effect will reroute our switches to the appropriate Xbox control. So let's start now. Okay. Now what's happening here is uh, the context and effect is going to go through all of our choices. This is the main menu, so we have access to all of our controls. And what I want to do is get rid of our settings part of this so that we can see the entire game. Okay. Now, let's say we want to play the canyon course. So I'm going to wait until it gets back around to right here. Okay, and now I'm on Canyon. So I just want to uh, I just want to signal on my A for that. And now I just want to play a par 3 hole. So again, I'm looking for my right key. Okay, and then when I get to my A, I'll make my signal, and that will choose it. And again, I'll signal on A because I want to choose the amateur course. There we go. All right, now I'm going to go in and play. Okay, and I'll just say press A to all of these choices to get me into the game. Okay, here we go. There we go. All right. So relax. All right, so I'm already at the point where I'm putting, and you can see that this is downhill, going high to uh, going from the right high to the left low. So I'm going to rotate my man here to go right. It's quite a lengthy putt, so I'm going to move us quite a bit over. Okay, now I'm going to go back to play, and it's not uphill or downhill, basically. It's just sloped. So I'm going to hit it per the power meter here. Here we go. Oh, that close to a birdie. Okay. There we go. And that's par. Our second example with PowerStar Golf is with an actual NeuroNode user. This user is using some very slight thumb movement and controlling the NeuroNode, and this was his first evening after installing PowerStar Golf on his system, and this is his video. And there's no sound here, so I will narrate, and there he goes. Pretty good swing. Again, it's activation, activation, activation to set the stroke, the swing in process, and then to set the power, and then to set the accuracy. There's another one, not too bad. It looks like he's on the putting green. It's good. And now this is his golf swing. Or sorry, his putter, his putt. This is for par. It's quite a distance for par, and didn't quite get there. But I thank him very much for making this recording for me. You'll notice that he didn't adjust his putter based on the slope of the green. So since then, of course, he's mastered that ability. That's an easier process than than actually the 3 activations required to swing. In the case of putting, only 2 activations are needed. You're setting your accuracy beforehand, and then you're just setting your swing with 2 activations, start, swing, and then the power level you want. Okay, so now on to our next example, and this will be pinball. This is a beginning game of pinball, so the user is going to control the flippers with a single switch, and then we'll also control the plunger. Again, with the same NeuroNode activation, but we will route it to a different Xbox controller. So there's 2 panels, one for the flippers and one for the plunger. And when we're on the flipper display in direct switch, we check mark to combine our switch 1 and 2. And what that does then is it kind of programmatically wires together switch output 1 and 2, and those will go to the Xbox controls for the left and the right flipper, and they will engage at the same time. So a single NeuroNode activation will activate both switch outputs for the left and right flipper at the same time. And of course, to start things, we need the plunger panel. And the plunger panel is where a single NeuroNode activation will cause a switch output, in this case out of switch output 4, which is connected to the Xbox control that's needed to shoot out a ball. And the other special thing it does, of course, is that as soon as you shoot the ball out and you switch out through switch 4, then it transitions to the flipper display. And that's one of the keys and the magic to this is rerouting the place where your switch goes. So when we're using the flippers, we're going out of switch outputs 1 and 2 from the C&E box. When we are using the plunger, it's routing that out of switch output 4. So those 3 controls are all controlled with single NeuroNode activation. And you'll notice that the switch design, each panel has its own switch design panel. So that's how you can get the complexity that you need to be able to map one activation from the NeuroNode or from your Jelly Bean switch into multiple controls of an Xbox or whatever device you're controlling. Okay, so here's an example. This is the same 18-year-old with spinal muscular atrophy that was playing the golf game. He actually played the pinball game first. So again, he's using the 3 Xbox controls, but controlling all of that through a single activation of the NeuroNode. And there's no sound on this video, but let's just run through it. Okay, and you see the C&E screen there, and you saw the plunger pop up. He went through the plunger, and then now he's on the flippers. So that's him controlling the flippers. And then this is another ball. So he did that with the plunger, and then it transitioned to the flipper display, the flipper panel, and that's him controlling the flippers. You'll see they engage at the same time because we've wired them together programmatically. There we go. And of course, if it goes right down the middle, no matter how good you are at pinball, you're not going to be able to stop it. So that's it. That's Xbox Pinball. And it's just a stop and a summary here. The context and effect really is a communication and control system, but with an emphasis on the control part of it. And you have 8 programmable wired switch outputs on the end panel. And that gives you a lot of leverage to control toys, robots, and especially gaming where you need multiple controls. And you notice that from the golf game, for instance, you could play the entire game with 6 controls, With a beginner's version of pinball, you can play all of it with 3 controls, of course, leveraged with a single NeuroNode activation. An important part of this is as you transition from one panel to the next, you can change your access method. And you'll notice, for instance, on the golf game, I did this where I went from switch scanning, where it's scanning through 8 possibilities, 6 of them being switch outs, the other 2 being one to go to navigation for playing, and the other going back to the kind of the launch screen for the game. Uh, to abbreviated versions of switch scanning to ultimately a panel where there's a single button where you're controlling something in very strict real time, in this case, a golf swing. But it's the ability to transition from one access method to another, going from panel to panel, at the same time you can reroute your switching that makes it possible to get that kind of leverage. The other important part of it is that these panels can be linked by context. So you can have them change by time of day, for instance. The context that you've seen in my examples are changing by countdown. In the case of a dining robot, the system understands that if you're not moving your spoon from compartment to compartment and you aren't feeding yourself within a certain time frame, then you must need other help. Or you want other things from the ecosystem. You want to say that you're finished, or you want to ask for more food, or you want someone to wipe your face. And the great thing about it is that person can be a diner with you rather than a caregiver next to you, since you have not only the control of the robot, but you have the communication ability that comes as part of it. The other thing that you can get from it, of course, is the RFID cards, where you can program these ecosystems and save them and then access them with the swipe of a card. So with the swipe of a card, I can turn this into a dining robot ecosystem. With another swipe of the card, I can turn it into a particular Xbox game. And that applies to using toys too. Could be very valuable in the classroom where you have multiple students and each student has his own or her own set of cards that relate to the experience that you want him or her to experience. Welcome to this demonstration of the Control Bionics context and effect, the CNE as we call it. This demonstration will be how to create an intermediate pinball game ecosystem to connect to an Xbox. So this will require 2 panels, one for our plunger to shoot the ball out, and then another for the flippers. In a previous demonstration, we showed how to create a beginner pinball game where the flippers were linked together. So a single activation of the NeuroNode would activate both flippers. In this one, we'll make the left and right flipper independent. First, what we'll do is we will just start with a generic panel, just a simple 1-button panel. And we are going to first turn this into our plunger panel. And the plunger panel will allow us to connect to the Xbox, switch out to the Xbox, to the control that sends out the ball. And first off, let's make it look a bit like it is a pinball game. So I'll get rid of this. And to start with, I will, let's say, sort by name. And I'll find some of my graphics here. Here's a pinball plunger. Any JPEG will work. The CNE app will scale the picture to the size of your button. Okay, so we have that. And I've got a WAV file that I can use for this. It's basically just pinball new ball, which is what I'm doing, shooting out pinball ball with the plunger. Okay, and let me check mark audio with press so that we get our sound effect. The graphics here and the sound effects are really more for the design part of this. Ideally, what we have when this is working is we have our user concentrating directly on the Xbox display and not really on the C&E window here. Okay, and we want to check mark this switch jack out that you see at the bottom right, because we do want to output from our C&E box to the Xbox adaptive controller. All right, so far so good. We're going to go with direct switch. Let's come in here and design our switches. So for button A, that's the only button we have here. We're going to make it so it's activated with a space from the NeuroNode. And what's tricky about this is we're going to, instead of sending this out of switch output 1 from the C&E box, we're going to send this out of switch output 4, because we're going to use switch outputs 1 and 2 from the C&E box for the flippers. Okay, so that takes care of that. And this is pretty good to start with. So let's start saving these. And of course, I'm not going to name it this. I'm going to name it something like Pinball Intermediate Plunger. All right, here we go. Now you heard that it was actually trying to output from this. So we'll fix that, put it into pause. Okay, so that's the first step. And let's also have it, when it gets to this panel, let's have it announce it. So down here in the panel text box, we'll put plunger. And what that means is when it transitions to this particular panel, it will announce plunger. And that's one of the tricks so that we don't have to look back to see where we are in our pinball ecosystem. So let's save it again. Okay. And you'll notice that our method of switching is right here, and it's direct switch. So it's not switch scanning, and it's not direct select like we would get with mousing over or with eye tracking. It's direct switch. And that looks good. So now I'm going to create my second panel, and that will be for the flippers. So let's say we have 2 buttons. And to clarify things, let me just get rid of this as the graphics. And before I write over anything, let me just come in here and save this as flippers. There we go. Okay, rather drab right now, but let's make some changes. Of course, we want it to announce flippers when it transitions to this panel. And let's give it some graphics now. So button design for the button A graphic, I'm going to give it a pinball left flipper graphic. And then for the button B, I will give it, oops, not Pac-Man, pinball. Oh, flipper, yeah. So flipper right. Okay, there we go. And I do have sound effects for these, so let me load those in real quick. These can be any sound effect WAV files that you have. Shorter is better, of course, because when it transitions to something else, you don't want it still playing the sound effect. All right, so I've got a nice kind of mechanical sound for my flipper here. All right, oh, shoot, we have Pac-Man. Let's fix that. That's good to show you a mistake. Let's go back to this, and this is flipper left. Okay, that should be better. Okay, and now let's once again save this. Okay, now a few questions. How do we access both flippers with a single switch, with a single NeuroNode? with the way that we're going to do it here, there's a couple of ways we could do it. We could actually scan from left to right in a fast sequence, but that's not great for a real-time arcade game. Uh, it could be highlighting your right flipper when you need your left right there without losing the ball. So instead, let's tell it that we want to use long press. And what this will do is it will allow a short activation to be my left flipper activation and a longer press, a longer activation to be my right flipper. Okay, that's good. And see anything else I want to change here. Oh, I do have to set my switches, of course. So here, of course, it's not 4 anymore. I want to switch out of switch 1. Now, buttons A and B are tied together. Button A is the short press, button B is the long press. So I just need to make sure that when I do my long press, that I get the switch out correct, and that's what I want. So I've got switch 1 out of my C&E box will be for the left control for the flipper, the left flipper, and then the right control will be switched out of switch 2. All right, and since I'm using long press, let me make it a little bit longer than 1/10 of a second. So I have to hold it 1/10 of a second, hold my NeuroNode activation or hold my jelly bean button pressed down for 2/10 of a second in order for my right flipper to be activated. Otherwise, it will be considered to be the left flipper, a shorter press. Say okay to that. Once again, save this as we go along. All right, now really there's only one thing that's missing, and that is what happens when we lose the ball. And that's where we add a little bit of context to this. We will come up here and go to what's called panel context and effect. And I'm going to say after, say, 10 seconds, I want it to time out and I want it to switch panels. And I'm going to switch panels to the plunger. And the idea is that if I'm not using my flippers for some amount of time, and that's programmable as you saw, it must be the case that I've lost the ball. So of course we want to transition to a different panel to allow us to shoot out another ball. And the magic of it is when we go to that panel with our same NeuroNode activation, we'll switch out switch output 4 instead of switch outputs 1 and 2. 1 and 2 are for the flippers, and switch output 4 is for the plunger. Okay, I think I saved this, but just make sure we did. Yep. Okay. All right, let me take it off of pause, and we should start getting the beginning of our game here. You see that it is counting down. If I press my space, you'll notice that it resets the countdown. That makes sense. The nice thing about this is if you're in danger of the countdown being almost over, you can, just like a nervous pinball player, you can activate your flipper and you can restart the count, even if you're not hitting a ball. No harm done there. Okay, let's let it time out.
Plunger.
And there we go. It's back to the plunger. Now, with our plunger, we don't have this linked to anything. We have it that it does come out of switch output 4, but that's not enough. We need to tell it that when we make our activation, do a couple of things. One is send a switch out from output 4 so that the Xbox adaptive controller is connected in a way that we shoot out another ball. But we also have to transition to the flippers panel. And we do that here in button design. And we just say on this link here, get the flippers. Move to the flippers, right? And then I'll save this again. Okay, there isn't much more to this. Now, when I do my activation,
Flippers.
It sends the output out of output 4, but it also transitions to the flippers. And here you can see that at the bottom here, I've got these animations. These are my animations for the output of the button I'm using. So short press is outputting through 1, long press is outputting through 2. In either case, when I engage one of my flippers, it resets my count, knowing that I'm still playing with an active ball. And of course, no activity here means I've lost the ball, unfortunately,
Plunger.
and it transitions back to the plunger. And that's our demonstration. Thank you very much. In summary, what is the context and effect? It is a device that is used with the NeuroNode or some other input device, jelly bean switch or proximity switch or the NeuroNode, and it's used to control robots, toys, and gaming devices. And the key is that it gives you this leverage. It allows you to take a single switch or maybe a couple of switches and leverage that through the context and effect app to give you multiple outputs. For instance, you saw that in the uh, Xbox pinball game where a single NeuroNode activation was giving you 3 outputs to the Xbox adaptive controller. And to a larger degree, the golfing game where a single NeuroNode activation was outputting through 6 of the outputs on the C&E to the Xbox adaptive controller to basically control the entire game of golf without any intervention. You see the data flow here. So the NeuroNode is the switch, is the activation that the context and effect application uses to route its switching and provide the context for with that USB connection to the CE box to set which output is on and which output is off in your switch jacks, and those switch jacks, of course, are connected to the types of devices that you can have, like the Xbox adaptive controller, the toys, and robotic controls like the OB dining robot. And with it, there are 3 primary types of access. And these types of access you can find in most all speech generating devices. But what makes this unique in some ways is that as you transition from panel to panel, you can change your activation method on the fly. So you may have one panel where you're doing switch scanning, for instance, with the OB dining robot, where you have 8 choices related to expressing some need for help, to direct switch, which on the OB dining robot was where you were actually moving the spoon from compartment to compartment to select the food, and then a long press activation from the NeuroNode to deliver the food. So that's direct switch, where a button is basically mapped directly to a switch out, with some nuance there because you can combine switches like you saw with the pinball example where the left and right flipper were combined, or you can use long press, which is what was used with the OB dining robot, where the short activation moved the spoon from compartment to compartment. That's the select food function. And then the long press is what delivered the food to your mouth. And then the third access method is direct select. That's like mouse or eye gaze control, where you directly move your mouse pointer or your dot into position over the button, and then you use your switch, your NeuroNode, to select that particular button. And of course, with this is the app that allows you to build these ecosystems. And an ecosystem is one to many panels that are mapped out to allow you to change access methods, to change what you're switching out. So, for instance, in the game of pinball, on one panel we were switching out to switch outputs 1 and 2, and on another panel with the same NeuroNode activation, we were switching out of output 4. And panels can be linked by button activations. So similar to speech generating devices, you can have a button that takes you to another panel, but along the same lines, you can also transition from panel to panel by context. And the simplest examples of context would be a countdown, so that if you aren't using your flippers on the pinball game, the countdown will eventually send you to the panel that allows you to use the plunger, and then use a different output to the Xbox to shoot the ball out rather than use the flippers. And then as soon as you shoot the ball out, of course, it moves back to the flippers display. You can also switch on things like time of day to bring up another panel. And ultimately, what you're looking for is these ecosystems that allow you to perform a task, some combination of communication and control, without caregiver intervention. In the case of a dining experience, not only can you control the robot, but you can express needs related to that dining experience through the communication part of the ecosystem. And that's it for the NeuroNode context and effect. I thank you very much for listening and getting to this point. Here are 3 ways that you can get in touch with us: my email address and telephone number, and then the URL for Control Bionics, simply controlbionics.com. Thank you very much for listening and being a part of this. We look forward to hearing from you.